Okay. So good evening, everyone. Thank you all for coming to our annual Seasons of Discovery lecture. I'm Johannes Haile Selassie, and I'm the director of the Institute of Human Origins, or IHO, at ASU. Let me start by thanking all of our board of directors and research council members for their continued support. Without that support, IHO wouldn't be here, or at least as successful as it is without that support. I want to also thank all of our regular members, the staff, research scientists, postdocs, and graduate students for being part of the IHO community. IHO, founded by the discoverer of Lucy, Don Johansen, who is among us today, sitting right in the front. So IHO came to ASU in 1997, and it's been here since then. And through all these years, it has become one of the world-leading institutions on human origins research. It is multidisciplinary, it's transdisciplinary, with its research ranging from fossil discovery-based to genetics, human cultural evolution, and extant primate behavior. All of these research areas come together to connect our past to our global future. IHO is also about training students, the next generation of human origins researchers. It's also about increasing public awareness and interest in understanding where we came from and where we're going. It has several K-12 and adult programs, outreach programs, and TRIPS programs. And these are like what we do almost every year. We have various programs that we run through TRIPS programs and also outreach. And if you're really interested, you can actually go to our website, iho.asu.edu, and become a member, because that membership provides you the opportunity to get our newsletters every time we have it, and also get access to our ongoing research and our upcoming outreach and TRIPS programs. Now, for this evening's Seasons of Discovery lecture, you will hear about some exciting new fossil discoveries from Ethiopia, from one of our IHO research scientists, Professor Chris Campisano. Oh, now it's better. These fossil discoveries were recently published in the journal Nature, which is one of the most prestigious scientific journals in the world. Now, Chris received his PhD from Rutgers University, where his dissertation research focused on the geology and paleoenvironments at Hadar, Ethiopia, the site made famous by Don's discovery of Lucy in 1974. He then started as a postdoc at the Institute of Human Origins in 2007 and transitioned to a faculty position at ASU in 2010. His broad research interests revolve around the chronology and environmental context of hominin evolution. Specifically, he is interested in characterizing ancient landscapes and their change across space and through time at varying degrees of resolution by integrating paleontological assemblages and depositional environments. This information, of course, provides a temporal spatial environmental framework within which to test theories of hominin and faunal evolution. Chris has been fortunate enough to work at the fossil hominin sites spanning the last 4 million years throughout Ethiopia and Kenya. And he is currently the director of the Hadar Research Project and a former co-director of the Ledi-Geraru Research Project, both of which you will be hearing about tonight. His research is not limited to Ethiopia and Kenya. He is also currently involved in research at 13-million-year-old fossil ape sites in northern India and 44 million years old early primate sites in western Texas. Wow. So without further ado, please join me in welcoming Chris Campisano to the podium.
Thank you. Okay, just checking everyone can hear me all right with this mic? Okay. All right. Get my timer started here. Okay, so hi everyone. Thank you all for coming here this evening. It's great to see everyone. Friends of IHO, some of my own family and friends. Looks like a handful of undergrads here for extra credit. I'll take that as well. So as this is one of IHO's seasons of discovery lectures, that's sort of the focus of my talk this evening is going to be on this theme of discovery, particularly as paleoanthropology is, for the most part, a discovery-driven field. It's a discovery-driven science. And I'll be talking about the evolving landscapes of human evolution, how we find fossils, how we fill gaps in the fossil record, and what that tells us about the diversity of our family tree, so to speak. And I'm going to be doing a lot of this talking about the Afar region of Ethiopia, where a lot of IHO scientists partake in research. I'm going to couch this talk in a bit of a historical narrative. So there's going to be some storytelling, lots of pictures, including some folks in the crowd today. But also from particular points in my own sort of journey through my career here. And paleoanthropology is inherently a multidisciplinary field, as Johannes mentioned. And although I'm the one up here sort of presenting today, I'm actually here representing a much larger group of a fantastic team, again, who you'll see plenty of photos of. And this work builds on decades of research by other people as well. So I may be the spokesman for things tonight, but I owe plenty of gratitude to plenty of other folks. And I will get to those finds eventually that Johannes was talking about that were recently published, but there's sort of a long history in getting to that and sort of building up this human fossil record to see what we have today. So raise your hand if you've seen this in some form, context. Thank you, Ian. Can you raise your hand higher? That's kind of what I figured, right? So this and variants of it, this sort of 5 or 6 panel schematic or icon is called the March of Progress. And it actually stems from a 1965 Life book series on early man that was republished. I actually have the 1972 version book here, if you guys want to see it. There's some interesting things in there that I'd open it up, but most of the pages fall out now. But it included this drawing by natural history painter and muralist Rudolf Zallinger, and you can see here again that sort of 5-panel March of Progress here. But there is a little bit of a problem because this was actually, if you open up the book, it's a 5-page fold-out with 15 different sort of progressions here. And it was never intended to imply a linear sequence. Again, he was a muralist, so he's used to painting these large pictures. He did this one, I think it's 135 feet at the Yale Peabody Museum. And it was basically, this is just a temporal span. And he never meant it to imply progress. And in fact, if you can read the captions on some of these, so the one on the left, Australopithecus, is this 8-million-year-old ape from Italy. You know, it says, what does it say? A likely side branch of man's family tree, clearly an aberrant ape, so not something that's on the human path. And then similarly with Australopithecus robustus, a little later in time, now Paranthropus robustus, an evolutionary dead end in man's ancestry. However, this sort of caught on, unfortunately, and in a later interview, the author of the book, this famous paleoanthropologist F. Clark Howell, stated, right, the artist didn't intend to reduce the evolution of man to a linear sequence, but it was read that way by viewers. The graphic overwhelmed the text. It was powerful and emotional. And so this, unfortunately, sort of gives this idea of progress in evolution, incorrectly, of course, and that somehow us, human sapiens, are sort of the end goal of this progress as well. And of course, it's been co-opted by various memes and comics, even one for the private foundation here that funds a lot of paleoanthropological research. And this Grateful Dead Skull and Roses one, actually, I have, which I won as an undergrad in my human paleontology class. And I learned just the other night that Curtis Marion, where is he at? He's right here, is a huge deadhead, and so I'm going to make sure I hide this after the talk. And we'll get back to this issue of diversity and progress towards the end of the talk, but we're going to have a little bit of history first here. So some of the perspectives on some of the sites I'll be talking about, and these are the 2 regions in the Horn of Africa where I do most of my research, so the Turkana Basin in northern Kenya and southern Ethiopia around modern Lake Turkana, and the Afar here in northeast Ethiopia, where you have 3 different tectonic plates and 3 different rifts that then come together to form this Afar triangle. And you can sort of see how Africa is unzipping down from the Afar to Turkana. And these 2 sites and what's in between them are about 1,000 kilometers between the Afar and Turkana, so about 600 miles as the crow flies. And they're the primary source of hominin fossils in Eastern Africa over the last 4 million years. And so we're going to do a little comparison between some of these sites too. But first, we're going to take a very far jump back in time to put my discussion of the Afar into some context. So before I was even born here, believe it or not, a French geologist by the name of Maurice Taïeb was doing his dissertation work on the evolution and geomorphology of the Awash River Valley that you see here, that courses through the Afar. And during this, he came across a handful of sort of fossil sites in the process. And we're going to focus here real quick on this yellow box. We're going to zoom in. And Taïeb eventually joined up with another geologist by the name of John Kolb, and they did a quick survey through the Awash River in this region, and shortly afterwards expanded their team, or created a new team with our own Don Johansson and Yves Copin to start the International Afar Research Expedition, or IARE. So this is a very generalized map of some of the areas that they visited in the early days of the IARE. So in 1971, again, Kolb and Taïeb did this quick survey. They went and found fossils at this Leadu site. And then Kolb in 72 went back and did a quick survey again at Leadu and Ledi and Meshulu and the Kariu, just before sort of the whole IARE group got together and went back to several of these sites, particularly Leadu, Ledi, and Huuna. And then finally, Taïeb had sort of this little secret that some people knew about, this other site called Hadar. And he finally brought them to Hadar after visiting some of these other sites. And according to at least the field notebook that we have from 1972, when Don saw Hadar, he said something on the lines of "far friggin' out," and I'm not sure friggin' was the exact word that you used. I'll have to confirm with that later. And then they went back in 1973, but before they got to Hadar, and this is going to come into play in a bit later, they ventured to this site Geraru in the northeast here, as well as these sites in the north, Magaitu, Amado, and Adaitoli. And then they went to Hadar and spent basically the rest of the time there in 1973. And of course, that's when they found their first hominins there. Don found the first hominins there. And in 1974, of course, Don found the famous skeleton of Lucy at 3.2 million years ago of Australopithecus afarensis. Interestingly, right before that season, John Kolb and a student named Liz Oswald went back to Geraru and did some work out there, which we ultimately got the field notes for as well. And again, that's going to come into play in a little bit as we sort of march through time here. But of course, over the next decades, research was focused at Hadar. And just like when they asked Willie Sutton, the bank robber, well, why do you rob banks? Because that's where the money is. Well, why do you work at Hadar? Because that's where the fossils were, right? Hadar is an impressive place, and we'll cover that too. So we're going to take a big jump to 1992, and the reason why, speaking of Lucy, is this was the scene in terms of fossils from Turkana and the Afar when I had to do an AP biology book report in high school. And one of my options I chose was the book Lucy. And as with most people who read that book, you're very captivated by sort of the stories that are told, bouncing around Africa in a Land Cruiser looking for fossils, and all I could think of was, that's really cool, but how in the world do you get a job doing that? And so at this time, Lucy was this sort of iconic fossil, obviously, but in 1992, at least, in terms of what was published, there wasn't much else from the Afar, right? There was Australopithecus afarensis from Hadar, and there was this much later fossil called Homo bodoensis, or rhodesiensis, depending on whose taxonomy you like these days. But most of the action at that time was actually down in Kenya at the Turkana Basin, where they had many more fossil species and this sort of diversity, again, of Paranthropus robustus, or the robust Australopithecines, Paranthropus, and our genus Homo. So they had diversity, they had multiple taxa. Now, part of this was because there was a moratorium on research for most of the 80s in Ethiopia, so a lot of work was getting done in Kenya that wasn't happening in in the Afar. But this is sort of when I was introduced to the field, and I was like, well, Turkana seems like it's the hot spot. And so actually my first several field seasons doing work were actually in Turkana. And while we're on this, I'm going to talk a lot about things like the Pliocene and the Pleistocene. These are different geologic epochs, how geologists carve up time. The Pliocene is roughly 5 million years ago to 2.6 million years ago. The Pleistocene is about 2.6 million years ago to just 12,000 years ago. This covers most of our time frame of human evolution. Pliocene, sort of the earlier part. Pleistocene, sort of the later half. So this was actually I still have this upstairs, the textbook for when I took my intro to human evolution class, or intro to biological anthropology. Some of you guys might be in that class now. This looks very different, our phylogenies. And so even 30 years out from that early man book, it wasn't a very crowded field in terms of fossils, and our family tree didn't have a whole lot of branches. We basically had the robust Australopithecines, right, Boisei, Ethiopicus, and Robustus, and then sort of the more gracile group that led to Homo. This was we didn't have a whole lot of branches in our family tree at the time. And these are all just sort of variations of the theme in terms of taxonomies. So another jump to 2001. Again, we'll tell you why in a minute. So for most of the 70s and 90s, work in the Afar was focused at Hadar and in the Middle Awash region. And towards the end of the 90s, in 2000, projects started south of Hadar at Takika and west in the Gona region. And the reason I jumped to 2001 as the starting off point here is this was my first season at Hadar. I was a graduate student and invited to work there. And Hadar is not a very big place. It's only about 10 kilometers wide and maybe 6 to 8 kilometers north to south. It's much smaller than all the other projects in the Afar. It's way smaller than Turkana, but the exposures and the fossils there are amazing. And it's difficult not to fall in love with working in a landscape like this. And again, I'll have to ask Don after the talk, but this might have been some of the sort of similar to the view he had when he first saw Hadar from the plateau. And I almost pulled out my 2001 Hadar field shirt, but I thought I'd keep the props to a minimum today. Otherwise, Ian's going to give me a hard time on Monday. So I'm a little biased, but I've worked at a lot of fossil hominin sites, and Hadar, again, is an amazing place to work. There's a lot of different hominin species out there where we have evidence of teeth from this side at one time and a skull from another side at another time and some hand bones and other teeth here and there. So most of the things we understand about some of these species are bits and pieces over space and time, even if there's a lot of them. Hadar is unique in the sense that we have this concentration of fossils. We have about 400 or so specimens of afarensis contained in this one small area over one small period of time, right? And in addition to that, we have all sorts of geological and paleoenvironmental information. And so, at least in my opinion, I think that combined, afarensis is one of the best understood hominin species. And Hadar provides this unique opportunity to test for environmental influences on morphological and behavioral change, within one hominin taxa over time at one location. So again, it's very unique. And of course, most of what we find are not hominins. It's all these other critters on the landscape. These are the ancestors of what you would find if you went on safari in East Africa today. And they also are what we use to recreate paleoenvironments or reconstruct paleoenvironments, particularly by people like Kay Reed, who unfortunately couldn't be with us tonight. So as a geologist, I have to include at least some geological slide here. And at Hadar, this is, we have two packages of sediments, if you will, two formations. You can see the strat section here on the right or left of what my wife calls my totem poles. And so most of it is the Hadar formation. It's about 2.9 to 3.5 million years ago, and it's all afarensis, right? And then above it, we have this little bit called the Busadima Formation. It has early Homo, our species, and stone tools. And it's better preserved to the west in the Gona. We just sort of catch the edges of it. Unfortunately, if you see that little blue wiggly line at about 155 meters that says disconformity, we have one of those. And what a disconformity is a gap in the record. And here it's at least a 200,000-year gap between about 2.9 and 2.7. In fact, at Hadar, it's probably a bit more. In other places, it's even more significant than that. And this is primarily due to sort of some tectonic uplift and erosion of the landscape, and we just don't have that preserved in the area. And this is unfortunate because, as you can see, one of these geologic groups has afarensis, and the other has Homo, and we're missing whatever happened in between, right? Whether one transitions to another, one goes extinct, and Homo immigrates from somewhere else, whatever it may be, right? We're missing this critical interval. And I also just real quick want to point out these little SH1234, DD123. These are the submembers of Hadar where, when we collect fossils, they're assigned to these different levels. These are our analytical units, and this will come into play in a little bit. So if we look back at how things evolved in 2001, we have Turkana up top that added 2 new Middle Pliocene species, so Australopithecus anamensis at about 4.2 million years ago. This was proposed to be the ancestor of afarensis. And then at the same time, but something different than afarensis, is Kenyanthropus platyops. And so we have started getting this Middle Pliocene diversity, if you will. In the Afar, we had the first announcement of Ardipithecus ramidus at about 4.4. At the time, they'd only published sort of a handful of teeth. This skull came much later. We have the 2.3 million-year-old Homo fossil from Hadar, from that Busadima formation. And then we have this interesting critter, Australopithecus garhi, at about 2.5 million years from the Middle Awash. So we're starting to fill gaps in both regions. We're getting a little diversity early on. We don't have just the 2 million-year-old diversity. We have sort of this mid-Pliocene diversity picking up at Turkana. But we still have this gap between early Homo and afarensis at 2.5 to 3 million years. So going back to this slide, this is going to pop up a lot as we sort of guide through. Remember, Hadar today is kind of boxed in, Gonas to the west, Akikis to the south, but no one had really been exploring to the east. And 2 Hadar and IHO members, Kay Reed and Charlie Lockwood, had gone through some of the old IHO archives from the IARE, and there was reports suggesting that this area in the Ledi might be a little younger. And so they thought, well, hey, maybe we can fill this gap there, right? Maybe there's something that's going to fill that 2.5 to 3 million-year-old gap. They were interested in the origins of Homo, and so thought that would be a good place to start. So in 2002, they started the Middle Ledi Research Project. Again, unfortunately, Kay couldn't be with here tonight, but the geologist they recruited to join them, Ramon Aerosmith, is. And then also, if you look at the very bottom left of the group photo, the guy in the white shirt, it's a guy named Brian Vilmore. You'll see a much older picture of him coming up in a bit. So they surveyed the Middle Ledi. They even found Australopithecus teeth, but they realized it was basically the same age as Hadar. It was basically an extension of Hadar. And so they got a permit for a much bigger area in 2004 to survey around and explore all these other regions, including that Geraru site that I had talked about. So they were sort of revisiting some of these earlier 1973-74 sites from the IARE. In 2005, Kay asked me to join, and at the time, it was called the Awash Mile Project. It is now the Ledi-Geraru Research Project. And since I'm showing embarrassing photos of all my other colleagues, I threw one in of myself. So here's a dirty version of me back when A, I had hair, and B, it was brown. And I have, you can't really tell here, but my very fancy 3-megapixel Nikon digital camera. And in fact, if you look at the group photo, the guy dead center in the back in the white shirt is our own board member, Tom Jones, who joined us that field season. And so I'm going to talk a bit here about, again, this Ledi-Geraru site. This is the Leodoita Basin. This was Kalb's Geraru, right? So the Geraru is the river that goes on the southern edge of this basin. So 2007, as Johannes mentioned, I joined IHO, so we're going to see what our family tree looks like at this point. Nothing has been added to Turkana since 2001. No new species recorded. Obviously more fossils, but no new species. Meanwhile, sort of a field season of fossils, no pun intended, in the Middle Awash. And so in 2002, you get Homo erectus here, just a little older than 1 million years. In 2004, we jump way back past 5 million years to Ardipithecus kadaba, found by our own Johannes Haile Selassie. And then Also, around 4 million years, Australopithecus anamensis, not that skull, but that's a good picture of it, which we'll talk about as well. And so things are really starting to fill out in the Afar compared to Turkana. But again, we still have that pesky gap between about 2.5 and 3 million years ago. So Kay and I kind of bounced back and forth between Hadar and Ledi-Geraru field seasons, and starting in about 2012, we started intensely studying, the whole team, this eastern area, including Geraru, which we call the Eastern Ledi-Geraru. And so both paleontology and geology. We had a lot of great maps and strat sections, and even knew where some of the fossil sites were that John Kolb and Liz Oswald put together. So we had a good idea, sort of a baseline to work with. And much of the work was done by 2 ASU PhD students that Ramon and I supervised, Dominique Garello and Aaron DiMaggio, and they've continued working on this, the geology of the site as well since then. And the key to sort of what we got out of the Eastern Ledi-Geraru were the dates that were coming out from the geology. And if you look on the left here, you can see all those sequences between 2.5 and 3 million years ago. So this is what was missing at Hadar and the Hadar region in general, but preserved at Ledi-Geraru. And so this is what Kay and Charlie have been looking for since they started this back in 2002. So knowing that, right, the Eastern Ledi-Geraru covered this critical interval, it became the focus of sort of the intensive search by the paleontology crews. Every one of these blue flags represents a fossil. And after, again, a couple of years of surveying, we hit the jackpot, at least the fossil hominin jackpot. An Ethiopian graduate student at IHO, Chalacho Sayum, found this mandible in 2013 in deposits that were 2.8 million years old. So again, after years of searching, we finally got our first hominin from at least the Eastern Ledi-Geraru. There's a picture of Chalacho celebrating afterwards. And what it represented was the earliest evidence of our genus Homo. It's about 500,000 years older than what we had at Hadar, which at the time was also the earliest evidence. So it went from about 2.35 to 2.8 million years ago. It's almost a complete half mandible, so if you take a mirror image of it, you get almost a full mandible. But again, the key is that it's filling that gap between 2.5 and 3 million years ago as a potential bridge, depending on how you view hominin evolution, between Australopithecus and early Homo. Back to our little IARE map. Again, if you look in the north, those sites that they surveyed in 1973 before hitting Hadar, in 2002, Johannes Haile Selassie, who at the time was at the Cleveland Museum of Natural History, got a permit to do a bunch of surveying in the northern part of the Afar. And in about 2004, he focused on an area that is now the Woronzow-Mille project and started finding hominids there as well. So I asked Johannes if he had any pictures from the early days, and he said, they're probably on Kodachrome slides and boxes in the garage. So I was forced to find this one, this Getty image, which is supposedly from 2005. Hopefully I still have a job come Monday morning. But Johannes and his team were uncovering some amazing finds as well. I've been lucky to visit Woronzow-Mille twice, and you can see the topography there is much different than Hadar. It's not these giant escarpments and great exposures of great thickness. So it's a very different terrain, but they've managed to find some amazing fossils from there in those low-lying sediments. So first is this partial foot. It's from the site of Bertelli, known as the Bertelli foot, and it is dated to about somewhere between 3.3 and 3.5 million years ago. So it overlaps exactly in time with afarensis from Hadar. But this is not an afarensis foot. This is much more primitive. It has an opposable toe, which Lucy does not and we do not, and is actually more similar to that 4.4 million year old Ardipithecus ramidus fossil. And so what this tells us is that at this time in the Afar, there's definitely two different hominids on the landscape, right? Whatever this is, plus Lucy, and they're locomoting around that landscape and moving around it in probably very different ways. Then in 2015, only a couple months after we published the Ledi-Geraru mandible, Johannes and his team published an entirely new species, Australopithecus Debunking, again, in that 3.3 to 3.5 million year time frame. Has a lot of similarities to afarensis, but it is distinct enough to be a new species. So now there's at least one, if not two, other hominins on the landscape besides Lucy at this time. And of course, the obvious question is does that foot belong to that species? And we're just all going to have to be patient until Johannes and his team help us answer that. They have a whole bunch of other fantastic finds, but importantly, they have afarensis at this time as well. They have a partial skeleton, a bunch of jaws and teeth as well. So they have, at Woronzoomile itself, afarensis and Debunking and potentially whatever the Bertelli foot belongs to. And they also have older sediments where they have this Australopithecus anamensis skull, which is the first skull and only skull of Anamensis. And sort of this has implications not only for making Anamensis sort of a little younger than we knew, but there were some cranial bones from the Afar that we thought, because of its age, must be Anamensis. But when compared to this skull, we realized, no, they're afarensis. So in fact, it makes an overlap between afarensis and Anamensis, as opposed to this continual ancestor-descendant relationship that had been presumed. So again, the more you find, the more questions start coming up. So again, the Anamensis discovery published in 2019, so we jumped to there just a little bit before pre-COVID. Again, no new species in the Turkana count in terms of finds. Again, lots of finds, no new species, but we're adding here to the Afar, in particular that middle Pliocene. So now, not only have diversity just at Woronzoomile or in the Afar, but throughout East Africa. Right, that 3 to 4 million year time interval is getting pretty crowded. And we've also now filled that 2.5 to 3 million year old gap. But of course, the sort of rivalries, if you will, between paleontological sites, Ledi-Geraru wasn't quite yet done. And so I'm going to talk about a couple sites here, again, in the Ledi-Geraru project, the Ledi-Deuta Basin. You can see the LD350, that's the early Homo mandible. There's a site just below it, LD302, and then about a kilometer north, LD760. And then much farther to the north, this area called Asboli. And you can see, maybe you might be able to make out the people just below that AS100 label excavating. That's it. So for the LD760, here's an aerial view of it. It's an area we call Turtle Flats because, very creatively, it's a very flat area and there's a lot of turtle fossil bits there. We have Omar Abdullah here pointing out a tooth, and I sort of want to use this opportunity to mention that our project and all the other paleontological projects in the Afar could not happen without the Afar people. It's their land. They are integrated into every aspect of our field seasons. They are part of our camp crew, our survey crew. They are amazing fossil finders. Again, these are things they see every day. And again, I just wanted to make sure that we acknowledge all the work that they've done. Down in the bottom left is a much older Brian Vilmore going through the screens. The top right is Kay Reed and Amy Rector. Amy Rector has now taken over the leadership of the Ledi-Geraru project from Kay after her retirement. And then the bottom is Amy holding a tooth in her hand. She likes to say, with the recent press coverage, this has gotten a lot of circulation that, if nothing else, at least her hand is famous. And here's what we found at those sites, a whopping 13 teeth. Again, we just published this a couple months ago. 13 teeth from 4 individuals. The first at the top is this 2.8 million year specimen. Again, this is just down the slope from where the mandible was found from early Homo. That site up in Asboli at 2.6, early Homo. And then sandwiched in between them is this 2.7 million year old 9 teeth that becomes sort of the point of discussion here. And these are definitely not Homo. And I'm not really going to talk about the LD750 tooth here. It's too much to get into. So we have Homo at 2.6, Homo at 2.8, and something else going on at 2.7 here. So Brian Vilmore at UNLV and Lucas Delazine at University of Arkansas, both IHO alumni, former graduate students. They led the study of the teeth. You can see here how AS100 is almost a spitting image of the early Homo from Hadar at 2.3 million years ago. So even though there's 300,000 years between them, they look almost identical. And then we were comparing the LD760 material to afarensis. And the canine at the top here, little different shape, very different wear patterns. And then the bottom shows your back bottom molar, your M3. And you can see, for people who study afarensis, it doesn't have these characteristic afarensis features. This it's called distal tapering, so those orange lines, it doesn't have that. It's more parallel, and it doesn't have this bilobate shape or contours that the blue lines show. So doesn't seem to be afarensis. It's not Homo. So what could it be? And we entertained a lot of possibilities. So could it be a late surviving population of afarensis? Right? It's 300,000 years younger. That's a fair amount of time. It's not afarensis, but maybe it's something afarensis evolved into. But if it's something afarensis evolved into, well, maybe it's a new species and not afarensis. Could it be ancestral to Paranthropus, right? The sort of nutcracker man. It also is not Paranthropus, but maybe it's something that leads to Paranthropus. However, Paranthropus shows up at around 2.7 million years ago in Tanzania. And if you assume that whatever was on the landscape split into Homo and Paranthropus, well, if we already have Homo, we can't be ancestral to something that's already on the landscape. Could it be this weird critter Australopithecus garhi? Unfortunately, garhi is only known from the upper teeth, and we had all the bottom teeth. And it would require a very different morphology and wear patterns between upper and lower dentition. So we kind of ruled that one out. And then finally, the other option is a previously unknown species of Australopithecus. And this is the only one that doesn't have any contradictions, at least. And so ultimately, Brian and Luke and the rest of us sort of settled on this final option. The key here is it doesn't really matter what we call it, right? What it is it's not early Homo, and it's on the same landscape as early Homo. Right? We weren't expecting this. And so it talks to the diversity of our lineage at this time, and it takes that mid-Pliocene diversity that we highlighted earlier and continues it into the late Pliocene. One of the few things we do know is sort of the general environment that it lived in. And I know this looks like a very busy plot, which it is, but there's a few take-homes from it. So all these dots, the blue, the purple, the green, these are all different faunal communities in Africa. So national parks, game reserves, things like that. This is called a correspondence analysis, plot based off habitat type. And all you really need to pay attention to is things on the right are more open habitats. So these are things that are more grasslands. Things on the left are more closed habitats, woodlands, forests, that sort of thing. If they're up towards the top, they're a drier habitat. If they're down towards the bottom, they're a wetter habitat. These red ones here are where most of the afarensis fossils come from. The last sort of throes of afarensis at Hadar around 3 million years ago starts to get a little bit drier. Right? We've noticed this for a while now, particularly through work that Kay Reed has done. When you jump over to the Ledi-Geraru basin, you're much more open and you're a little bit drier as well. So this is this transition from afarensis to where we have the early Homo material and this new Australopithecus material. We haven't plotted the Asboli site in this one, but it actually might even be a little bit drier than the Ledi-Geraru and Grumaha sites. That's sort of in process right now. If we just look at the fossil sites and throw in some pictures to get you some ideas, again, you can see how Grumaha and Ledi-Geraru, where early Homo and Australopithecus is separate and more open, more grassy than what we have for afarensis, which of course, to me, begs the question, of course, well, is this shift in environments at this time responsible for this shift from afarensis to early Homo and whatever this new Australopithecus is? And that's a whole other topic about climate change at 2.8 million years ago. This open environment is also supported by some isotopic work that we've done. So there are two different photosynthetic pathways. Grasses use one type called C4. Shrubs and trees use another type called C3. And those isotopic signatures from that photosynthesis is recorded in the vegetation, and then it is recorded in the teeth of the animals that eat that vegetation. So we can distinguish between animals that browse and eat leaves on the left here, and animals that graze on grass on the right. And if you eat a bit of both, you're kind of in the middle. And so at 2.8 million years ago, where we have the early Homo teeth, you can see that most of the animals in the landscape, at least at this site, are in the grazers or mixed feeder category. And then as you get a little younger, as we expected, things are a bit more in the grazer category. So this supports that open environment. And again, we haven't run the numbers yet for the Asboli site at 2.6. What you can see here in the yellow, that spot right there, that star, that's the early Homo specimen, that's the mandible. And what's interesting is it's actually one of the few animals on sort of the browsing side of the mixed feeders. And if you compare that mandible and the star here versus the red, which is afarensis, primarily from Hadar, it actually falls right about the average. And so what's interesting is you have early Homo in a very different environment, right? Different morphology, but whatever it's eating is at least broadly similar to whatever afarensis ate, at least in terms of its C3, C4 proportions. And again, we're still working on the Australopithecus teeth. It's actually in process right now. And so we'll get an idea of whether it was eating something more similar to afarensis and early Homo, or maybe something different altogether. So there's plenty of things we don't know about these hominins, obviously. We do know a lot about their general paleoenvironments. But we just have a handful of teeth, right? We don't know how they moved around the landscape, what their cranial capacity was, which one of them were making stone tools, which we have at 2.6 million years ago. Was it both of them? We're working on this, but of course it requires more fossils, right? How did they interact? Did they carve up the landscape so that they didn't interact? Did they wave to each other as they went to work in the morning? Right? There's lots of different species of monkeys that share the same space but carve up their resources. Chimps in West Africa and gorillas in West Africa coexist, right? They have separate strategies. So do they compete for resources? We don't really know. And these questions aren't exclusive to the Ledi-Geraru hominins, right? This is the same sort of question we have with Debunking and afarensis, right? They're at the same site, and then at Hadar, you only have afarensis. So how are they differentiating between Woronzomile and Hadar, or within Woronzomile? And this is a whole other project that the Hadar and Woronzomile teams are collaborating on. So we've come a long way in the last few decades, right? So this is how it sort of was in the early 90s. You had Hadar at Middle Awash. You had Gona, Dakika, Ledi-Geraru, Woronzomile. I haven't even gotten to talking about Mile Logia, which we'll skip for this one. And again, back when I sort of first got introduced to paleontology, this is how things looked versus today, right? You have the Afar fleshed out more than Turkana now, and you can see that the diversity wasn't restricted to 2 million years and later. It goes back at least 3.5, 4 million years and extends over this entire time span. And so, in fact, diversity is the norm. It's not the exception. And so this, of course, stands in stark contrast to the last 30 or 40,000 years ago, where it's just been Homo sapiens on the landscape, right? This is a very odd time in human history where we're the only hominins on the landscape versus this past. And so here's a chart a lot of us use by Bernard Wood and Eve Boyle, and this is sort of the scene at 2010 and takes into account the rest of the hominin record, not just the Afar and Turkana. But you can see, again, in 2012, we had the Bertelli foot. In 2015, we had Ledi-Geraru Homo specimen, as well as Debunking. That find of the anamensis skull from Woronzomile then extends and overlaps afarensis and anamensis. We extended early Homo in Leodoita and add a new Australopithecus species. And this is just in the Afar, right? So Gary Schwartz up there and his group working in South Africa and Drimmelen a couple years ago, if you look at the Homo erectus line here, that blue line, extended that back to about 2 million years. And within 50 centimeters of it, they had specimens of an entire different genus, Paranthropus robustus. 10 kilometers away, at the same time, you have Australopithecus sediba. So you have 3 different genera of critters within 10 kilometers of each other. So again, diversity seems to be the rule versus the exception when it comes to human evolution. And you'll see that there's no lines drawn here like in my textbook from 1994, right? It's far too complicated. All these new discoveries, again, create often more questions than answers. And so here's our field project from 2005. We'll be going back in January, hoping to find more of these fossils to complicate things even more for the good. And then I just want to end on this is a drone video by David Feary to give you guys an idea, again, of the landscape. And I wanted to wrap things up again by circling back to the theme of this lecture series in terms of seasons of discovery. And it's really amazing the things that we can extract from fossils now. By their scratches and microscopic pits on teeth and the isotopes preserved in them, we can tell what they ate, right? We can do CT scanning and 3D reconstructions of limb bones and hands and feet to figure out how they walked, right? We're quite literally squeezing blood from a stone. But none of this is possible without finding the fossils in the first place. Like I said in the opening, paleontology is largely a discovery-driven field, and it's about putting in the time, right? Writing the grants, doing the logistics for the field season, putting boots on the ground, the same spot over and over and over every year if we have to, so that you can maybe catch a glint of enamel from a tooth, or maybe you see a rock that looks a little bit different than the other rocks on the landscape. And I've been privileged enough to work with some amazing groups in my time there, including this, where we're staring straight at the sun for our group photo, which didn't turn out too well. But this is actually a neat little image of sort of our environs as well. And people ask, well, how come I don't take my wife to the field? And I think this picture will probably sum it up for the most part. And on that, again, I just want to thank everyone for coming here tonight, thank the various people and groups that I've worked with that have made this research possible, that have shared slides and photos or information for this talk. Again, I'm simply a representative for a much larger group of fantastic people and have had the pleasure of working with over the last several decades.